Before we get started, let's take another look at Paul's ticket. As you may remember, Paul's computer is IPv4 only. Now, nothing about Paul's ticket flat out screams that there's a network latency problem. In fact, it looks a lot like the other tickets we've looked at. But remember what we said earlier. Don't get into the habit of assuming that two different problems are similar just because they look the same on the surface. Sometimes network latency can present as a network failure. If the network is slow enough, it can cause some applications to time out and just stop trying, so they fail. To the end user, this looks like something is just broken, and in fact, even if we ask really good questions, we usually cannot determine whether there's a network latency issue or just an outright failure just by talking to the end user. We have to actually get on Paul's computer to find out what's really going on. So let's do that right now. Here we can see the page can't be displayed error that Paul reported. But notice also that the status icon on the tab is spinning, indicating that Internet Explorer is still trying to load the page. Up to this point, we've been using the Windows command prompt to diagnose and troubleshoot, but I want to show you another alternative, the Windows PowerShell. It's available on all Windows 7 and later operating systems, and you can get to it by going to the Start menu and just searching for PowerShell. The commands we're going to use are exactly the same as we would use at the Windows command prompt. In fact, all of the commands we're using are part of the Windows operating system and are not tied to either the command prompt or PowerShell. Let's start out by pinging and ARPing the default gateway. We'll do ping 10.10.1.254. And that looks good. ARP-A shows the correct dynamic ARP entry for the gateway, so we know that layers 1 and 2 are good. Now let's ping the intranet site, ping intranet.netluxia.com, and we get a response initially followed by a request timed out, another response, and then another request timed out. If you look at the ping statistics, you'll see that it reports a 50% packet loss. Now, this is just over 4 pings. This could just be a temporary blip in the network, or it could be part of a larger pattern, but we can't tell which it is with just 4 pings. So what do? Well, we could set the ping command to ping over and over again, but then we'd have to sit there and constantly watch it, which would take us away from other things we could be doing to troubleshoot the issue. Instead, there's another program I want to show you called Colasoft Ping Tool. This is a third-party program that is not part of Windows, so you will need to download it, and I'll give you the link in a moment. Ping Tool gives you a visual representation of ping response times over time, so you can easily spot patterns without having to wait a long time. You can also leave it running in the background while you do other troubleshooting and then come back to it later to review the results. You can see that we're getting the same 50% packet loss, and it's very consistent. What do we make of consistent 50% packet loss? Well, we can make several guesses, and there's nothing wrong with guessing, but we still have another tool at our disposal. We clearly have a layer 3 issue on our hands, so we'll use traceroute to try to find out where the packets are getting dropped. Okay, now what's going on here? It goes from switch 1 to R2 to R3 to switch 4. And you don't have to take my word for it. We'll look at the topology diagram in a minute. So why does the intranet IP address 10.11.0.11 show up 4 different times? Well, this has to do with the way traceroute works. I wish I could tell you that traceroute actually just traces an individual packet from its source to its destination, but that's not actually how it works. Traceroute sends a series of packets, and under normal circumstances, all of those packets will get a response. But in this case, because we have 50% packet loss, not all of those packets are getting a response. The asterisks you see scattered around here indicate a response that went unanswered. In other words, a packet that was lost. Now, if you count the number of asterisks or lost packets, there are 8. But in total, there are 12 requests. Now, this is more than 50% loss. It's actually about 67%. Why is this? Well, remember, we're still running a continuous ping in the background using the Colasoft Ping Tool. So that's going to skew the results a little bit, and that's okay. But we still don't know what's causing the intermittent packet loss. So what do? Well, we're going to run another traceroute. Now, why are we doing this? Well, the first trace route gave us some pretty strange results. By running a second one, we can compare the two to see what, if anything, is different. Remember, there's no magic bullet when it comes to network troubleshooting. In other words, there's no defined set of commands to run that will always tell you the cause of the problem or even where it's located. Now that the second trace route is done, let's go through and compare it line by line with the first one. We have switch 1, followed by R2, followed by R3. But look at the fourth hop. On the first trace route, it's switch 4, but on the second, it's switch 3. It looks as if the packets are taking two different paths. Let's take a look at the topology diagram to get a better view of what's going on. The packet goes from Paul's computer to switch 1. From there, it goes to R2 and then to R3. On the first trace route, the next hop was switch 4. But on the subsequent trace route, it was switch 3. So it appears, based on our trace route output, that the packet is taking two different paths. Sometimes it takes the path through switch 3, and sometimes it takes the path through switch 4. Assuming that one of these two paths is not working, that would explain why we're getting 50% packet loss. So we've definitely isolated the problem to a layer 3 issue, but as yet we don't know the cause. But before we get too far ahead, let's take a step back and review what we've done so far with Paul's problem. Initially, we observed that Paul was experiencing 50% packet loss while pinging the intranet site. We used the Colasoft ping tool to visualize the packet loss and ping response times from Paul's computer to the intranet site. Ping tool is a great tool for when you're dealing with a network latency issue or when you just want to monitor performance over a period of time. After we discovered the 50% packet loss using ping tool, we ran a trace route which showed us that the packet was taking two different paths, but it didn't tell us which path was failing. I'm not going to get into the technical details of how traceroute works, but suffice it to say that the traceroute does not always tell the whole story. What this means is that you cannot always use a traceroute output alone to conclusively determine the cause of a problem. This is one of those cases where we have to be very wary of what traceroute is telling us.